Hello everyone. Today we are going to solve the next question on bit manipulation concept. So the question is exceptionally odd. Given an array n with like n positive integers where all numbers occur even number of times except one number which occurs odd number of times. Okay, so we have to return a number which occurs odd number of times. So for example, if we see here the number of occurrences, if we find one is occurring two times, two is occurring two times, and three, the number of occurrences of three is three. So the odd number of occurrences is of number three. So we'll return number three. So the output is three. So if we see the next test case, like next example, so the number of occurrences of 5 is 2, 7 is 2, 2 is 2. Okay, so number of occurrences of 5 is 3, 7 is 2, and 2 is 2. So we are returning 5. Okay, so the first approach which we can think is find the number of occurrences and return the number which is odd. Okay, so what I can do, if I solve this question using brute force. So we want one count variable which counts the number of occurrences of that number, and we'll use two loops. So suppose we are finding one this number, this element occurs how many times in an array. So again I need to traverse to the same array from beginning, and I have to check if error of I, okay, if it is equal to error of j, then we have to count, increment the count. Okay, and here what I did is, so I'm traversing from this array and again I'm checking in the same array how many times it occurs. So one, from again zeroth index we are checking, so it comes one and again it's two. So the number of occurrences will get, the count is two, and if we have to check if count percent 2, if it is equal to 0, that means it is a even number, then we don't have to do anything. If it is not even number, then we have to directly return, what we have to return, we have to return the number. Okay. So and let's say if there is no such odd number, then we'll return minus 1. So if I run, okay, so you can see here the output is 3. So if I add one more 3 and one more 1, and increase the value of n, if I run, we should get the output as 1, as 1 is occurring 3 times. Okay, so in this way we can solve this question, and here we can use the concept of bit manipulation, which makes the question easier, like to solve it easier. So this is the brute force approach. Okay, I'll solve using bit manipulation concept. So we know the XOR. So in the last question, in the last to last question also, we have seen XOR X is what, 0, and 0 XOR X is what, X. So if we see these two properties, then we can say if there are even number of x in an array, then the XOR of those will be 0, and 0 XOR x will be x. So if we see here, if I take the same example, 1 2 3 2 3 1 3, okay, so if I do XOR 1 XOR 1 will be 0, okay, again 2 XOR 2 will be 0, again 3 XOR 3 XOR 3, it will be 0 XOR 3, which is 3. So again we have to do all this XOR, like 0 XOR 0 XOR 3. What will get, will get answer 3. Okay, So we have to do the XOR of all the elements. Then automatically the numbers which are occurring even times, they will get cancelled and will get 0. And the odd number of times, one number will be in the result only, as we can see here 3. So 0 XOR 3 is 3 only, so I'll get the output. Okay, so here what I will do, it's an integer, same thing, x. Initially we can use 0, or I'll use error of 0, the first index and the first element. And from I'll start from 1, index 1 to 10, and I'll do the XOR. X is equal to x XOR of XOR with error of I. Then at the end, the number which will be in x, that will be the number which are occurring odd times. So here we will return x. So if I run this, okay, here you can see we are getting the answer. So I'll use the test case. Okay, you can see here we are getting output. So in this way we can solve this question, and using the bitwise concept, this XOR concept, we are solving this question in a simpler way. As we have seen the brute force approach, and this is the efficient approach, we can see the difference. So yes, this is the like fourth question we are solving on bit manipulation. Okay, so yes, done. Thank you.